11 years ago. Robots were set a simple task: open a door. But one after another, with 10,000 people watching, they fell. Today, robots are breaking world records and learning football skills in a single day. That didn't happen by accident. It happened because of 40 years of robots falling down, getting back up, and someone, somewhere, writing down exactly what went wrong. So how do we get from robots collapsing to breaking world records in such a short time? Let's find out. In 1986, Honda started a robotics program almost nobody knew existed. Not a press release, not a product launch. A quiet internal project locked away with one specific goal: make a machine balance on two legs the way a human does. The first version, E0, took 5 seconds per step. 5 seconds. That's painstakingly slow. Honda kept going anyway. E1, E2, through to E6, refining the walk a little more each time, year after year, with no public announcement and no guarantee any of it would work. By 1993, they'd added a torso and arms, with the upgrade to the P series. P2, unveiled in 1996, was the breakthrough most people have never heard of. 210 kilograms, fully self-contained, no tether, no external power cable, no support rig. It walked on its own. Nothing like it had existed before. By the time the P series reached its peak, with the P3 model, the iconic look was almost there. But there was one more upgrade needed before Honda's robot became a worldwide cultural phenomenon.
One of Honda's dreams has always been to create a humanoid robot to be a helper to people in society. So at this time, we'd like to help you meet the result of that dream. So please say hello to ASIMO.
ASIMO, which stands for Advanced Step in Innovative Mobility. 130 centimeters tall, it walks smoothly. It climbed stairs. It recognized faces. It responded to voice commands.
We also can use acoustic cues, calling ASIMO to raise his attention.
ASIMO, look at me. Oh, there you go. All right, mate.
For an entire generation, ASIMO was what a robot looked like. Museum tours, world's fairs, school science lessons. If you grew up anywhere between 2000 and 2010, and someone said the word robot, there's a good chance the image in your head was ASIMO. One image in particular outlived almost everything else from that era. ASIMO mid-stride, foot connecting with the football. A small, almost throwaway demonstration. Decades later, it's one of the most recognizable images in the entire history of robotics.
He shoots! He scores!
The first hint, long before anyone used the phrase robot sport, that a robot kicking a ball could capture public imagination in a way that pure engineering demonstrations never could. ASIMO wasn't alone. Sony had its own contender, QRIO, a smaller, more agile humanoid that could run, dance, and adapt to changing surfaces. History remembers ASIMO. Almost nobody remembers QRIO existed at all. That's worth sitting with for a moment. Even the robots that don't become icons still push the whole field forward. Most of robotics history is invisible by design. ASIMO kept improving through the 2000s. By 2004, it could run, not just walk. The first humanoid to genuinely leave the ground with both feet at once. But the promise that came with it, a useful humanoid robot in everyday life, never quite arrived. Honda quietly halted ASIMO's development in 2018. Formally retired it in 2022. 22 years after it first stepped into the spotlight, ASIMO proved the humanoid robot could walk convincingly. It never figured out what to actually do once it could. That question, what is a walking robot actually for, is what the next 20 years of robotics history spent answering. And the answer that emerged wasn't a butler or a museum exhibit. It was something with worldwide mass audience appeal. It was sport. While Honda was perfecting a walk, a completely different idea was taking shape elsewhere in the world of robotics. In Nagoya, Japan, a small group of researchers held the first RoboCup, robots playing football, against each other. The stated long-term goal sounded almost like a joke at the time.
From all the different kinds of soccer are doing different kinds of research towards the goal of 2050 of having a team of robots that can beat the FIFA World Champions in a fair and practical game.
That's right. The plan was to eventually build a team of fully autonomous robots capable of beating the human World Cup champions by 2050. Nobody in that room in 1997 thought they'd live to see it taken seriously. RoboCup kept running anyway, every year, building slowly toward a target that's still decades away. At the same time, a quieter and stranger thread was developing in the United States. Mark Rabert had been building leg robots at MIT and Carnegie Mellon since the early 1980s, in what researchers simply call the leg laboratory. Not humanoids yet. Basically just hopping machines, one-leg robots that balance through pure feedback control, learning to stay upright the way a human balances on a pogo stick. In 1992, Rabert founded Boston Dynamics. For nearly 2 decades, almost nobody outside robotic circles knew the name. Their first genuinely human-like walking robot wasn't built for sport or for show. It was built to test chemical protection suits for the US military. PETMAN, the name standing for Protection Ensemble Test Mannequin, was unveiled in 2009. It was the first bipedal robot to walk with a gait that actually resembled a human's, weight shifting naturally from foot to foot, arms swinging for balance the way ours do. The robot that would eventually learn to do backflips and, years later, learn a football trick shot in a single day, started his life walking back and forth in a hazmat suit, testing for chemical leaks. Nobody watching PETMAN in 2009 could have predicted where this was heading. That's true of almost everything in this story. In March 2011, an earthquake and tsunami struck Fukushima, Japan, triggering a nuclear meltdown. Workers needed to go into areas too radioactive for any human to survive. There was no robot in the world capable of doing that job. DARPA, the US government's defense research agency, decided to fix that. They launched the DARPA Robotics Challenge. The goal? Build a robot that could navigate a disaster zone, drive a vehicle, walk over rubble, open a door, climb stairs, use a power tool. Things any able-bodied adult does without thinking, and no robot on Earth could reliably do it all. The finals took place in June 2015 at the Fairplex in Pomona, California. 23 teams, 10,000 spectators, $3.5 million in prize money, and robot after robot fell over. Some teetered for a moment first, as if hesitating before going down. Some twitched afterward, motors still trying to execute commands that no longer made sense. The crowd groaned every time. One reporter actually stopped a DARPA official mid-briefing to ask, with genuine concern, "Is the MIT robot okay?" DARPA's own program manager, Gil Pratt, tried to talk the audience out of caring. "It's a pile of aluminium and copper wire and software," he said. "I don't cheer for my laptop." And then, a moment later, contradicting himself completely, "But people cheer for these robots. And of course, when it falls, we all feel terrible. Nobody could help it. Watching something try, fail, and try again, even something built from aluminum and copper wire, turns out to be one of the most human things there is to witness." Not every robot fell, though. Atlas units, fielded by teams from MIT and others, stumbled but then recovered, stumbled again, and just kept going. Scoring points not by being perfect, but by being able to fail and continue. That distinction mattered more than anyone realized at the time. The winning robot from Team KS used a hybrid design, wheels built into his knees, switching between rolling and walking depending on the terrain. Pragmatic, slightly inelegant, and exactly what worked. The challenge ended. The aluminum and copper wire robots went back to their labs, and an entire generation of engineers carried forward a lesson that no spec sheet could have taught them. A robot doesn't need to be perfect. It needs to be able to fall down and get back up. A solid life lesson right there for all of us. A year after the challenge ended, Boston Dynamics released a video of Atlas doing a backflip, then parkour, then dancing, The same hydraulic Atlas platform that has stumbled through Pomona kept improving year after year, until falling over stopped being the headline and became something closer to a rare exception. In 2024, Boston Dynamics retired that hydraulic Atlas entirely and replaced it with a completely redesigned electric version, built not as a disaster response demonstrator, but as a genuine commercial product. Around the same time, companies that didn't exist during the DARPA years, Unitree, Figure, a dozen others, started releasing humanoid robots of their own, building on exactly the lessons the DRC had forced into the open. Lightning, breaking a human world record in Beijing. Atlas, learning a football trick shot most professionals never master in a single day. None of it starts in 2026. All of it starts with a robot that took 5 seconds per step in 1986 and a robot that fell on its face in front of 10,000 people in 2015. 40 years, quiet labs, public failures, a generation of engineers who kept going anyway. That's the part of the story nobody tells when they show you a robot scoring a goal.